Well, we are going to move on to our next topic here, and we spent, the better part of yesterday and some of today learning about pavement design software and design sustainability and resilient pavements and overlays for urban areas, and now most recently with managing our pavement systems. Our final topic, we want to turn it over to Dan Rozycki, the president of the Transtec Group, about the future of highways. Dan is going to look at some myths and truths about how technology will drive the future of pavement design and construction techniques to meet the transportation needs of the future. As mentioned, Dan is president of the Transtec Group. For those of you unfamiliar with them, that's the pavement engineering firm that brought you Hyperpave, ProVal, Compass, mixed design software, 25 years of pavement research for the FHWA, and over $60 billion of design, build, and P3 highway projects throughout the world. Certainly a tremendous resume, and you can read that on the screen. Dan is a civil engineer from the University of Texas at Austin, and we are certainly very, very pleased to have him talk to us about the future of highways. So with that, I will turn it over to Dan Rozycki.
Thank you very much, Art. Good afternoon. Jeremy did an excellent presentation, which is extremely relevant as we think about, let me get this started. There we go. Which is extremely relevant as we think about just how technology is shaping the way that we use roadways and the way we design and build roadways. And that's what this presentation is about. I'm going to do my best in 60 minutes or less to really kind of show you just a quick snapshot of so many things that are going on, of the way that technology is really changing our industry. I mean, and that, as I started to see that happening, I just took a personal interest in trying to get ahead of this and trying to understand what are all the different ways that technology is going to affect your job and my job. And that's kind of how this presentation came about. So, as Art mentioned, let's start with just a couple of myths and truths about how all this new technology is changing pavement design and construction. A lot of you have probably heard about all these Google type companies and Uber and Lyft that are, working on like a fully driverless downtown taxi. Well, the truth is it's a bit of a myth, because what they are finding is they like a lot of things that I've read, what they are saying they can do about 95% of the circumstances that they need to be able to have a truly driverless downtown taxi. But that last 5% in terms of safety and really understanding just all the different conditions, it's just not possible. And they just haven't been able to quite crack the code entirely. So downtown driverless cars, the truth is it's just too complicated. It might be here someday, but not nearly as quickly as all the marketing and buzz claims. What is coming and is less marketing and is more real is driverless trucks on the highway. Because if you think about it, that's a simpler problem to solve, because you've got fewer inputs in terms of no pedestrians, no traffic lights. It's more of a controlled access system. And so that's something that's actually happening now. And there's companies like Auto and Starsky Robotics that are actually testing. And Too Simple is a big one. They're testing fully driverless 18-wheelers on the highway right now. Another myth number 2 is, Uber claimed that in 2020 we were going to see these giant drones that carried passengers that they were calling air taxis were going to start. They were actually going to be flying those in Dallas in 2020. Well, that never happened, because same story, like they claim that they can get it all figured out, but they just haven't been able to solve such an incredibly complicated equation. And they lost so much money on it that at the end of last year, Uber actually finally sold off that whole division of Uber because it was just losing too much money. So they sold it off for, I think, like $75 million to a company called Joby. And Joby has now said, yes, it's still going to happen, but maybe not till 2023. So I'm not going to hold my breath. Myth number 3 is, so many of us think like all this crazy Jetson stuff that, people are marketing and advertising, it's not really going to happen. And you have a point that fully driverless cars are still a long ways off. I mean, at least, maybe 20 years or more before we can really solve that problem. But there is a lot of crazy stuff that is already happening today, and I'm going to try to show you a lot of it as quickly as I can. And here's the first one. Company is called Tortoise. Do you see this? Look at this. This is ridiculous. This is a driverless scooter. I don't even understand what this is for. And who needs this? Now, the tortoise company claims that you need this because the problem that they think they're solving is that driverless scooters, is that scooters are currently littering the sidewalks of downtown areas where there's a whole bunch of scooters out. And so what this will enable you to do is you'll use your smartphone to call the scooter and the scooter will come to you. And that way we won't have quite as much scooter trash all over the streets. Now, if you think that's ridiculous, I agree with you. But you and I are wrong, because not only has Tortoise been able to raise tens of millions of dollars to develop the driverless scooter, Lyft and Bird and Waymo have also invested tens of millions of dollars each to develop this. This is a real thing that people are really working on. And so my point is, it's this kind of new technology that is coming to our industry is important to you and me, because just look back over the history and we have seen how technology has really redefined so many industries. I mean, remember newspapers? Remember when radio DJs used to be live? Retail is shrinking and shopping malls are becoming Amazon distribution centers. I mean, the list goes on and on. If you look at all the different industries that have just been completely transformed by the advent of technology. I mean, I could go through the list here. I mean, you know, we don't buy music very much anymore. There's streaming services, and so bands now have to go on tour. They can't sell albums anymore. And I mean, just the list goes on and on. I mean, even you know, rural activities of farming and ranching, you know, that is such a small percentage of our workforce compared to what it used to be. And the list goes on with drones and 3D printing, and libraries are now all online, and self-checkout at the grocery store. And so my point is, there's so much going on that's affecting you and me, that it's important for us to get ahead of it. And so here's just some quick samples of some of the hundreds of things that are already happening today that are not the future, they are the present, that directly affect our jobs. So Nexar, for example, is a company that sells dash cams, just regular dash cams that, you know, that taxi drivers or even regular civilians like you and me will have on the front that are, you know, shooting video out the front of the car or sometimes out the back. But what's unique is Nexar is collecting all that video. And they're harvesting all that video and GPS and information. They're selling all your information to governments and companies. So, you know, over time, is that going to change demand planning and traffic engineering? So that's one. So the Carbon app that Dr. Gregory was showing is crowdsourcing, and there's other applications of that kind of technology. So Robotics is a company that is doing total pavement management with the smartphone on your dashboard, and using the camera on your smartphone to collect information. And they have over 100 cities doing pavement management. And so the question is, could that change pavement smoothness standards? Built Robotics is selling autonomous construction equipment, and I'll show you some of that later. So that is fully autonomous, real construction equipment. Meanwhile, driverless cars could eliminate the need for parking lots and highway lanes. So that could change the way we do pavement design and construction. Google already has more road data than most state DOTs. That's kind of a major thing to kind of process and think about how that's going to affect. Companies like Waze and Virginia DOT have partnered together, and they have snowplow-based live monitoring of roads, and it just goes on and on. The newest, craziest thing is this idea of $0 economy. So the idea here is your car generates a lot of data. And we are almost to the point where it's going to be easy for you, if you want, to sell that data to marketing companies and to the Googles who want to buy that data so that they can understand how you use your car and how people, the behavior patterns of drivers. And the idea is, if you could sell the data from your car, you could eventually pay for your car. So your car becomes $0, and that's what they mean by $0 economy. But the old adage to remember, and Art and I were talking about this earlier, is if your product is free, like if you're not paying for a product, then that means you're the product. And that is just something to kind of keep in mind. But how are all these things going to change the way you and I work and the way DOTs operate? You know, for the past 5 years at all these different industry events that I've been going to and learning about all this, you keep hearing the same 3 lines over and over. The future is electric, the future is autonomous, and data is the new oil. And I am generally a skeptical person, but I'm starting to see that they may have a point. All right, so here's the outline of this presentation. All these different things that could directly impact your job. So I'm going to show you a whole bunch of crazy new technologies that are coming to roadways, and then we'll talk about something that's a little bit more directly applicable. We'll look at automation in highway construction, and then we'll look at what changes are coming to pavement design and pavement construction. All right, so part one, new technology for roadways. So about 25, actually it's up to over 30 states now that have some kind of program in the deployment of all this new technology for different kinds of highway activities. So 30 to 35 different states are doing some sort of program now at looking at all this new technology. And here's one example. So this is Drive Ohio. So Drive Ohio is run by Ohio DOT, but it's not funded by Ohio DOT. It is really just sort of like this umbrella organization that tries to be the information hub of all these different programs happening throughout Ohio, including smart corridors that counties are running or universities are doing. And so they all kind of work together and they sort of share their information with Drive Ohio. And there's about 14 different projects within the Drive Ohio umbrella that are happening now. And it's everything from using drones to having sensors on highways to vehicles that are talking to cell towers to smart traffic lights that are, have cameras and sensors that are watching everything. And so it's there's a lot of states that have sort of different levels of what they're doing. And what they're really all getting to is, could roads with proper sensors and technology start doing things like generating their own energy, or could roads start assessing themselves or do their own pavement management or even repair themselves? And the reality is, yeah, a lot of these roads really are already starting to do that. And so I'm going to show you some of these now. Okay, so this is the Ray. The Ray is a test section on I-85 in Georgia. And the Wattway company has glued solar panels onto the rest area. Wattway has also done this in France. So that's another example. And this is solar panels right onto a rest area. Solar Roads is a company in Idaho. It's this husband-wife company in Idaho where they've done lots of different ways of building these solar panels that you could drive on. Caltrans looked into it, but Caltrans decided against it. Another major company is called Solar Roads out of the Netherlands, and this is one of their test sections that they've built. So the people who like the idea of solar panels on pavement say that we're generating free energy, and it takes, they estimate, about 220 square feet of solar panel to power one house. So, that could generate a lot of free energy. The critics say it's that the cost doesn't work out, the return on investment doesn't work. And when you drive 18-wheelers on these panels, they don't last very long. So, and then there's also just the issues of texture and friction. So what is becoming more realistic is maybe we could do solar panels in parking areas, maybe on shoulders, but probably not main lanes. So that's one idea. So the Ray, this organization, this test section in Georgia, is this big nonprofit, and they've got about 14 of these different, or 12 of these different projects that they're running right now. So it's not just solar panels on pavement. The Ray is also testing out fancy road striping that can talk to driverless vehicles. They're looking into things that are more for climate, and then they have these fancy weigh and motion devices that actually check the tires as you drive across the device for the texture to make sure that your tread is thick enough, and it can also measure tire pressure. So there's just a lot of new technologies that the Ray as an organization is working on. All right, here's another big one. This is, it's called dynamic electric vehicle charging, but this is recharging your Tesla as it drives down the highway. So this is equipment built by Qualcomm. You're looking at a test section in France. It's embedded in the roadway, and then you drive over it, and through induction, it recharges the batteries in your car. There are test sections in Israel and Sweden, and actually the Illinois Tollway Authority looked into doing this as like a whole new way of collecting toll revenue, but they couldn't get the return on investment the math to work out. And so people who like this idea say, just imagine if you could just drive your Tesla over DEVC, then you could have, it goes forever. Like imagine these driverless electric cars that never even need to be recharged. But skeptics say that this is not such a smart idea because you're installing this in the pavement. So it's expensive to install, it's expensive to maintain. How are you going to maintain the pavement around it? And, batteries on Teslas and other electric vehicles, the range is getting better and better. So it may not be all that necessary. Now, the most realistic idea of this is maybe like a downtown circulator bus, kind of, like a small shuttle bus that's downtown. As it circulates around, if it could recharge, that could be possibly have like a positive ROI. Now, as far as electrification of roads go, this is the organization that is leading the way in the United States and most of the world. It's at Utah State University, and it's an organization called Aspire. And they just got a $50 million grant from the Department of Energy to really start electrifying roads. And so they are leading the nation at developing these ideas and looking into real applications for state DOTs. Here's another way of doing free energy. This is a video from a company called InnoWattTech out of Israel. And about 10 years ago, they built a test section where you put these little blocks or piezoelectric crystals. And when you squeeze them, it makes a voltage that turns into electricity, right? So if you drive over thousands of these, and the cars are squeezing them that are in the pavement, then you can create enough electricity to either store on the roadside or push it back into the grid or use it to light the highway at night. And so this is real test sections that they've built, and these are actually working properly. And so in the city of Merced, California, they built a test section to try this out. And in San Antonio, Texas, working with Texas Department of Transportation and the University of Texas San Antonio, they're building test sections to evaluate this right now as well. So embedded sensors, there are hundreds and hundreds of kinds of different embedded sensors that people are developing now because technology is pretty cheap. So the one on the left is called ePave. It was developed by the University of Buffalo and a university in China. And this little sensor has one of those piezoelectric crystals in it. So every time you drive over the sensor, it recharges the sensor so it can last, indefinitely. And the sensor measures temperature and humidity and pressure and stress, and all that feeds into software. And so if you've got temperature, humidity, pressure, and stress in a pavement, you can then use that to predict potholes and cracks before they happen. So that's what that sensor does. It predicts potholes and cracks before they happen, which is pretty cool. The sensor on the right is already commercially available. It's by HiCob. And it functions to measure surface temperature, and then it also has a 3-axis sort of magnetic field to be able to count cars or watch traffic or alert the authorities if a vehicle leaves the roadway under like icy conditions. And so, and that lasts about 5 years, and it's battery powered. And then this is like the newest sensor that's out. This is from a company out of Israel called Valoran. So this sensor looks, it's kind of like a light can in a runway. And as you see here, it is wireless, so it talks to cell towers. It lights up, so you could use it to direct traffic, and it's solar powered, so it can last, indefinitely. And so it is used, and they already have installations of it in other countries, not in the U.S. yet, but in other countries it's been installed to alert drivers if there's a hazard, or change traffic flow, or alert drivers if there's, icy road conditions, that sort of thing. And so, so far this one is actually doing really well. So a huge segment of all this new technology is what people refer to as V to X. So that means vehicle, and the X stands for everything. And so you see on this graph or on this chart, V to V means vehicle to vehicle, V to P, vehicle to pedestrian, and so forth. And so this is sort of the next big wave of all vehicles communicating, not only vehicles talking to each other, but if you could talk to a person's cell phone, you could alert them if you're approaching a crosswalk. If you're talking to a cell tower, if cars are talking to cell towers, they could start providing like traffic information and traffic congestion information. And then vehicle to infrastructure is like talking to traffic signals. And so that could, you could optimize the traffic signals to improve traffic flow. And so if you think about it, that can really provide a new safety benefits that are already starting to be implemented and tested out. And so imagine if the cars are talking to each other, you could have like do not pass warnings. You could alert a car if there's a blind curve and there's a car stuck on the other side of that curve. You could alert cars about work zones that are up ahead, or help with intersection movements, or if there's a person or a bicycle in a crosswalk up ahead, or left turns. So there's just a lot of information and a lot of safety features that we could do with V2X. And so V2X can improve traffic flow and safety and change the way we do lane markings and joint patterns. Roadside units are these little boxes that you stick into the side of the road that are sort of a major component of V2X, and they're referred to as DSRC, which is dedicated short range communication. And it helps the cars talk to each other and talk to the cloud. And new cars are already doing this. New cars are already sending data to cell towers, and that goes to the manufacturers right now. But that data could soon, instead of going to manufacturers, could start going to other databases. And that data is called basic safety messaging. And that basic safety messaging is generally about 138 kinds of information that go from the car to the cloud 10 times a second. And so right now, if you've got like a 2018 or newer vehicle, the car manufacturer is capturing all this information from your car passively without your knowing it. And it's everything from, is your turn signal on? Are you depressing your brake? What is the accelerometer in your car saying that you're going uphill or downhill or sliding? It's just a lot of information. And then we are able to send information back to the car through what's called traffic information management data. And so companies are starting to use this the BSM data with connected vehicles, and we're starting to develop these crowdsourced pavement conditions, and so that can affect the way we measure smoothness or potholes or friction. So V2X, huge field. You could also imagine using it for driverless truck platooning. We can use it to, so adaptive cruise control is available on new cars. Cooperative adaptive cruise control is where the cars talk to each other. And so that's coming, and V2X is going to enable that. Imagine if you had cars talking to each other and talking to the cloud, you wouldn't need toll gantries anymore on toll roads. That's what people call like a digital wallet. And then all that could ultimately change the way that we pay for roads. And if you think this is crazy, there are well over 40 million cars on the road today in the US that are already sending data to the cloud. And they estimate that, within 10 years, the majority of cars on the road are gonna have this capability. All right, other things that are going on. In Finland, a company called Vaisala has already built a real-time pavement management system that doesn't use any of those fancy million-dollar vans that you hear companies are using for like automated distress data collection that state DOTs use. So they don't use any of those vans. They just have sensors and cameras set up in key locations. That black hockey puck you see on your screen is a sensor that's embedded in the roadway for measuring information. And then this company, Vaisala, cut a deal with the postal service of the nation of Finland, basically the USPS of Finland, and they've strapped cameras and sensors onto every delivery truck. So instead of having these million-dollar vans, they've got a $50 pack of sensors and cameras on every truck that is collecting all this data in real time. And Vaisala claims that all this constantly feeds into what they claim to be an artificial intelligent system that they have that's doing real live pavement management in real time, which is pretty amazing. Back at MIT, as Dr. Gregory was talking about, there's another program at MIT called the Sensible City Lab, and they have one project called City Scanner. And for all the trash trucks in the city of Cambridge, Massachusetts, they strap some sensors and some cameras on, and now those trash trucks are basically reporting data live in real time as they drive around and pick up trash. And it's everything from temperature and moisture to air quality. They also have accelerometers on them where they are able to measure road smoothness. And so every time there's a pothole or a major bump that accelerometer picks up, it automatically reports it to the Department of Public Works, and then they can go out and check it and fill potholes instantly. And all of that data is free, live, real time on this web page that you see the example of the screenshot that I've got here. So that's what Cambridge, Massachusetts is doing. So that's another use of new technology. Here's a company called iCone that is selling work zone products like cones and barriers and stop signs, and they're all connected to the cloud. And so the purpose of this is by having work zones that are connected to the cloud, by having work zones that are connected to the cloud, you can have devices that could actually send data to connected cars. So imagine, your backup camera screen or your data screen or your infotainment screen that's in the middle of your dashboard console in your car, that could light up and alert you that there's a work zone coming. Also, the same devices could also alert workers. So you could put a cone or you see that construction zone pin, you could put that far out at the leading edge of the work zone. And if a car crosses into that, it could sound an alarm or a siren that alerts everybody in the work zone that a car has breached that work zone. So it could really improve safety for work zone. 3M has been selling for quite some time now these machine readable highway signs. So this is a highway sign that in daytime you see what it looks like on the left, but what a connected vehicle or a driverless car with the right sensor sees is the image on the right, which is, so it's infrared ink that is printed onto that work sign. So the car, instead of reading road work ahead, is actually reading that two-dimensional barcode, which is giving the car far more information. So it could do things like wrong way driving detection. It could do things like tell the car about upcoming work zones or other information, or lane changes or narrowing lanes, any of that kind of information. All right, here's one that's a little more crazy. So we've all seen drones. That's not new. And drones are starting to fly over traffic. That used to be a thing that was prohibitive, but now it can. So here's a drone that flies over traffic, looks for cracks, and seals them. Now, if that's bananas to you, it is bananas, because I don't think the researchers really considered the idea of 18-wheelers in traffic. I think 18-wheeler versus drone, the drone's not going to win. But this is a real thing. People are actually using drones for all sorts of things. There are other companies that are actively using drones for pavement management, where they're flying over roadways. They have really high resolution LiDAR and high resolution cameras, and they're able to identify small cracks and use that to develop maintenance plans. And they're also able to use it for pavement management systems. Here's another one. This is glow-in-the-dark striping. So there's an engineer named Dan Rozycki in the Netherlands who several years ago conceived of the idea of why can't mix photoluminous powder in with thermoplast and be able to create glow-in-the-dark stripes. And so he's developed that, and they have some real test sections, as you see here, and it works. And so they're now starting to develop this technology and roll it out for other things. And so there's a university in Mexico that is developed, and now I think Cemex is starting to sell glow-in-the-dark cement. There's other people that are developing glow-in-the-dark aggregates that you can embed into lane stripes to make glow-in-the-dark striping materials. So that's becoming popular throughout Europe. There's a lot of new research for coming up with the de-icing of pavement, to come up with ways to do it more effectively and less expensively. So the University of New York in Binghamton has done a geothermal experiment. So they're drawing water from a nearby lake, and they've made this underlayment under the pavement. And they have found that it's been very inexpensive and very effective as a way of being able to, basically run warm water through the tubes in a geothermal application to de-ice pavement. Item B that you see there is a new product from a company called SafeLane, where they have embedded brine into a top coat of aggregate that they claim sort of works for 7 seasons. That it'll thaw the ice using the brine. And then our friends at Iowa State University, the Concrete Pavement Technology Center, they have come up with a way of actually running electric lines to just heat the pavement using electricity, and they've shown some real success with that. And they actually got profiled on the Today Show recently. All right, so of all the new technologies, this one is the kookiest, but it's a real thing. Glow-in-the-dark trees. I hear you. I mean, I can't actually hear you, but I agree with you. So scientists, researchers at MIT identified luciferase, which is the enzyme that makes fireflies glow. And they've realized that they can shove it into leaves of trees and make the whole tree glow in the dark, and will light our road at night for $0 by glow-in-the-dark trees. They claim that they've already got trees glowing up to 4 hours per day, and that they're optimizing it, and they're pretty close to reaching 8 hours per day, which is ridiculous. But and if you think that this is not a real thing, there are independent, unrelated research projects doing the exact same thing in Denmark and Israel right now, where they're trying to make glow-in-the-dark trees. And the one thing that I have not found is, do they understand the difference between evergreen and deciduous trees? Because I don't understand how this works in the winter, but that's what they're doing. All right, so that is a quick snapshot of a whole bunch of different technologies that are coming to roadways. And the thing that they all have in common is, you and I are not developing these things. It is Google and Tesla and Uber and Silicon Valley and all these crazy new technology, high-tech companies have now infiltrated. I mean, the same way that they've infiltrated all these other industries, like newspapers and retail and all of that, they are now in our industry. And what I don't see is they don't really know transportation needs the way we do. They know technology. So transportation needs are our expertise, and we need to be more involved. And what I keep hoping for is some sort of federal highway, ACPA, NAPA joint program to work with the tech companies so that the technologies that are steering us in that direction will be the technologies that are most useful and relevant for us, that meet the long-term needs of transportation that we need. All right, we're moving on to part 2. What's new in automated construction equipment? Okay, so hang on just a second. Let me correct one quick thing. All right, hang on. Okay, let me show you some things that are new in automated construction equipment. So there was a great report that the Federal Highway Administration put out a couple years ago that actually has a really great summary of all different things that are new in highway construction. Art is going to make a copy of this presentation available to you later. If you're not able to write this down, write down the report number, you can ask me, or I can get you a copy of the report. But it's really good about lots of new things that are coming in terms of automation for highway construction. Here's kind of an overview, or a graphical overview of what that report covers. So it's everything from the planning stage all the way through survey and design and construction and maintenance. And so in planning, there's 3D laser and LiDAR that are using, and we're using drones now for planning to do remote sensing. And then in the surveying, there's so much new developments in 3D modeling and mapping that's happening. Also, 3-dimensional design is happening, and I'll show you some examples of some of that here in a minute. And then machine control, as you likely know, is just becoming more and more prevalent, and automation is getting more and more advanced. And then in inspection, there's intelligent construction, intelligent compaction, and just lots of new technologies that are coming to pavements for automation. And so we talked to some of the biggest companies in highway construction and asked them sort of what is some of the newest advances that they see happening for automated construction. And these are some of the examples they gave. But I want to show you kind of the newest one that I saw. So sit back, relax. This is a company called Built Robotics. They are, not surprisingly, out of California, and they are fully autonomizing construction equipment. So take a look at this. All right, cool, but terrifying. They are currently selling their construction equipment mostly for contractors on wind farms. This is a testimonial from their website. And as you see, I mean, I'll read a little bit of it. Built Autonomous Dozer is the real deal. They've already finished hundreds of pads, and the pads are for these wind turbine farms that this contractor is building. And he refers to it as, our skilled operators do the complex stuff, and the Built Robotics is fully autonomous, doing what he describes as the more mundane work. So this is not the future. This is actual autonomous construction equipment that's happening now. So then I called Gunnar Zimmerman, talked to Rolf before he left, and talked to Ron. And these are some of the newest things that G&Z is kind of working on. And for them, they're really focusing on trying to make their equipment as adaptable as possible. So using the same tractor for both the paver and the belt placer, for example. They're also seeing that skilled labor shortage. They're developing better sensors and more sensors so that paver adjustments will be more automated and easier to control. And then they said that they're continuing to use telematics to keep enhancing software and diagnostics. And so a quick refresher, telematics is not new. That's been around for a while. That's using GPS and and sensors to make improvements of the performance and operation of equipment for all these different benefits for assets and reducing theft and those kinds of things. So that's not new, but they believe that there's still a lot of room for advancement by enhancing the software that runs the telematics that they have. So I talked to Kevin Klein at Gomeco, and he said kind of the newest thing coming out of Gomeco is the Navigator software that controls all the accessories on the paver. And now, as you see in that red arrow in the image, it's all on an easy touchscreen that's at ground level. So no matter where you are, you can make adjustments to paver performance and make configuration changes for tie bar inserters and transition adjusters. And they say that the new, what's also great about it is that it's all retrofittable to existing accessories that you might have. We also talked to Wortkin, and Tim Nash explained how Autopilot 2.0 is the newest thing that they have for stringless and for optimizing profiles, because it's one tablet that you can take from the pole straight to the paver, and it'll make 3D models now instantly, or you can import 3D models that you already have, and it works with all the existing equipment. The other thing that Wortkin had is a new rear lift, for the start-stop of the paver to reduce that bump that happens. And so, so the operator can now program that in so that as the paver comes to a stop, the rear mold can adjust a little bit and try to reduce the bump that often happens. And then we talked to Trimble, and I'll show you two videos that they sent me. So, Sight Vision is full-on augmented reality. So remember the difference between virtual reality and augmented reality. Virtual reality is, everything you see is an animation. Augmented reality is actual, is the video or the image in front of you with graphics overlaid on top of, the real image. And so, so I'll show you an example of that. So they've got Sight Vision has come up with some pretty cool new advancements, and so they sent me this video using a testimonial from Cold Spring Construction. They're out of New York, and they're a ACPA member. So here's the video.
But this is the first opportunity that we've had to use the Trimble Catalyst with the Google software, and what it enables us to do is to go out and look at the design to be constructed overlaid on the actual site conditions in real time. The ability to actually visualize what's going to be constructed before it happens is an enormous advantage.
Pretty cool. So that's augmented reality, where you have, the graphical image is overlaid, looking right through the camera of what's actually out there. Here's a second video from Trimble. It's pretty cool. Pretty interesting stuff. So, so that's pretty wild. All right, things that are coming in paving equipment. Real-time profilers, not new, but we're finding more and more state DOTs starting to embrace and accept real-time profiler equipment, and that technology keeps advancing as well. And as we saw, machine guidance is becoming more and more popular. Augmented reality, as we just saw, is now coming to paving equipment. And then not only the autonomous construction that you saw from Built Robotics, but also crash trucks are becoming a more routine thing in certain states for having autonomous features on them. Trends we see in paving materials of things that are coming. So Iowa State University is leading the charge on performance engineered mixtures, and they've just published a beautiful publication on that that's got a lot of great guidance, and so state DOTs are embracing that, so that's becoming more widely accepted. Of course, recycle and reclaim materials is increasing in popularity. Embedded sensors, as we already talked about. Changing work zones to be able to understand connected vehicles and eventually autonomous vehicles. That is a hot topic with a lot of state DOTs. And of course, resilient pavements, right? So sustainable pavements, but also resilient pavements that can weather major climatic events and be able to keep moisture out of pavements, whether it's massive flooding or coastal hurricanes, things like that. And then just more real-time and remote indicators during construction. These are all the hot topics that we keep seeing that state DOTs are interested in pursuing and advancing, which is great. So in conclusion, so we see a lot of new tech that is going to change the way we pavement engineers and contractors are working in the field, and so what we see from all that is, our DOTs partnering enough with contractors and even with the engineering firms to work together to work through these changes together to ensure that as they adopt these new things, it is in concert with contractor needs and contractor abilities. So I think there's area for improvement in that. All right, last section of our presentation. So we talked about crazy new technology that's coming to roadways. We looked at new technology that is coming to equipment and paving. But let's look at the specifics of how paving design and how pavement construction could really change in the future. So this is a press release that just came out last week. So this is brand new. So Ferrovial is a gigantic engineering firm that is owned by Cintra. Cintra, you might know, is that big Spanish company that operates toll roads throughout the US. They've got toll roads in Virginia and Indiana and Texas, and they see all this new technology coming, right? So Cintra is a giant multi-billion-dollar legacy corporation that sees all this new technology coming, and they see that it's being driven by the Googles and the Ubers and the Teslas, and they're trying to get involved. So they've made this big announcement that they're going to start creating the toll roads of the future by partnering, you see that first bullet there, with Microsoft, with 3M, and Capsch. Capsch is one of those roadside units. They're a manufacturer of roadside units like I talked about earlier in the presentation. And so they are going to work together to try developing these concepts of what the roads of the future could be. And so you see there in their other bullets, open solutions for connected corridors, whatever the heck that means, and safety and mobility to make roads better. So they're trying to get on board, but they're not the only one. This is the competitor to Cintra. You don't hear about them as often because they don't do quite as much work in the US, but they are active in Canada and Europe. They're called Vinci, and they're out of France. So they're basically like Cintra and Ferrovial, but they're from France. Vinci has a program called Leonard, and Leonard, which I'm guessing is a play on Leonard da Vinci or Leonardo da Vinci. So Leonard is the same kind of program where they're developing these concepts of the roads of the future to try to get ahead of all this technology and help state DOTs sort of conceive of what these roads could look like if you start to incorporate all these new technologies that I showed you earlier in this presentation. All right, but here's the last one that I want to show you now. I got to switch screens a little bit, so bear with me. Hang on. Okay. Let's see. I don't know, that did not work. Let me try it a different way. Give me just a second. Okay, all right. So this is a company called Cavnu, and this is their homepage, and the animation is why I'm switching so that you can see the animation. So what Cavnu wants to do is similar to what Cintra and Vinci are talking about, where they're going to develop these roads of the future. But Cavnu is not an engineering company and not a contractor and not a construction company. Cavnu is a company wholly owned by Google. So this is Google in the highway business. This is Google jumping the fence and getting into your industry very directly. They want to become the new toll road operator. They want to become the new concessionaire. And so this video, we'll show it one more time and I'll walk you through kind of what they're doing. They're saying, take your traditional highway with too much congestion and let's replace the middle lane with like a fully autonomous lane in each direction that talks to cell towers, and you've got driverless 18-wheelers and driverless cars, and even if your car is not driverless, you'll merge into the driverless lane, take your hands off the wheel, and it will become driverless, and we'll develop that technology. And then in the downtown urban area, we'll have driverless shuttles that'll work on these lanes. And so Google's plan is that they want to provide all this technology. They want to get in the highway business and build all this high-tech roadway, and that is the direction they're trying to go. Let me switch back to to the presentation. And so there we go. So that is what Google is trying to do. And what's crazy about all this is they think that the way that they're going to generate revenue is not just from collecting tolls. They want to get in this business because they see billions of dollars in being able to generate revenue off all this data. Like these lanes could have could recharge your electric vehicle as they drive across it, and they could charge you money for that. Or these lanes could send advertisements to the data screen, to the that infotainment screen in the middle of your console, and they'll generate revenue that way. Or they'll put ads in those driverless shuttle vehicles, and they'll generate revenue that way. So so Google is very much interested in getting into the highway business. And I'm sorry, one last important thing, they're already doing it. So Google just a month ago signed a contract with the Michigan DOT that they are going to study for the next 2 years a stretch of Interstate 40 in Michigan. And if they think that this concept that I just showed you in the video is a viable alternative for Interstate 40, they're going to build it. And they did not have to, they cut this deal with the Michigan DOT by offering to do their own study for $0. So the way they're able to get this agreement with Michigan is they offered to do it for no money. So Google is paying their own money to do it. And at the end of 2 years, if Google determines that this could be a positive return on investment, they have full rights to be able to build this on Interstate 40 in Michigan. All right, here's another graphical example of how roads could change in the future. Because if you think about it, if cars are talking to each other, and if cars are talking to the cloud, and if cars are starting to become more driverless, then we may not need as much pavement. I don't like the sound of that, but that's a real thing. We may not need as many lanes. We may not need lane striping. We may not need medians. We may not need traffic lights. We may not need traditional crosswalks. Some people think we may not even need parking lots in the future because the driverless cars and Ubers and Lyfts and people aren't going to keep owning vehicles in the future. So so this is kind of a quick representation of what the future could look like. And so that's a real consideration. So let's start talking about the specifics of how pavement design and construction could change in the future. So as you think about all these things that we've covered, DOT planning is going to change because these traffic patterns, human needs are changing as cars become more connected and driverless. Also, these big design build projects that happen around the country could actually become more popular because as all this technology is advancing, the DOTs don't have 40 years of historical legacy knowledge of how all this works. They're going to rely more on private sector companies to be able to answer a lot of these questions about how you develop that. And so you see that's what's already happening with Google offering to build a toll road on Interstate 40. Also, as more of these Uber, Lyft, these shared vehicles happen, you're going to have fewer cars that are owned by people, so there'll be less need for parking lots. We may actually have to start creating, imagine a right lane that is just for dropping people off and picking people up for all this Uber and Lyft type vehicles that are becoming more popular. And then geometric roadway design is going to change as well because CAVs will be a lot more precise than human drivers, and we may not even need lane striping as much. And so we'll look at that in just a minute. And then electric cars are becoming more popular, which means we're buying less gas, which means we're generating less gas tax. So how we fund roads of the future is going to have to change. So some specifics that could change pavement design. So driverless 18-wheelers are being tested right now. Driverless cars on highways is a possibility, and that's being tested right now. And so if you imagine if they're driverless, then there's no lane wander anymore, right? That 18-wheeler is computerized, so it's going to be right in the wheel path all the time. And so less lane wander could actually be good for concrete versus asphalt because you've got more, localized impact loading that's happening as you're driving over the same wheel path every time. Narrow lanes also leads to greater impact and greater fatigue on that narrowed pavement. And so that could also be a good argument for concrete over asphalt. As you do these driverless truck platoonings, that will lead to reduced following distance between trucks, which means you have less recovery time from the load, between but in the time between trucks or in the headway. And so reduced following distance could also be good for concrete over asphalt. Also, as we move towards driverless trucks, the hours of service is going to lengthen. And so we'll have more trucks moving more hours per day. So there'll be increased nighttime traffic, which is a totally different design for asphalt. And so that could be good for concrete pavement. And then autonomous truck corridors. So this is something, a concept developed by our friend Tyler Lay, who's a professor in Oklahoma, of like, let's have dedicated lanes for driverless electric trucks, whether they're powered overhead or they're just electric trucks that are powered underground. But we could develop these autonomous truck corridors. And if you think about that, that is absolutely a great argument for concrete over asphalt. Other things, embedded sensors, embedded electrification of roads. Some people want to put, like in Colorado, they want to put Wi-Fi in roads, they want to put fiber optics in roads. All of that is a good argument for concrete over asphalt. Also, the increased demand for resilient pavements. As we've well seen, concrete does a much better job of surviving major weather events over asphalt. Something that is changing, but is not necessarily a strength for concrete. If we start to remove signalized intersections, then we may not have the running and shoving of asphalt at intersections where we have turning movements and stopping and starting. But that's just a change that could be coming to the way we design and build pavements. And then future work zones, as vehicles are talking to each other, and just the increased need for pavement smoothness, because all of these new technologies can only function on pavements that stay smooth over a long period of time. And so that's a good argument for concrete. Finally, Vision 2040 is a report written by the American Concrete Pavement Association that touches on a lot of these topics. And it's a great report. It's freely available on the ACPA website. I highly recommend it. It's good reading material. So in conclusion, number one, it's not you and me, it's tech companies that are driving the future of this transportation. They don't know long-term transportation needs, we do. So we need to be more involved in that. Number two, tech is also changing these contractor abilities from workforce issues. And so how are we partnering with DOTs to make sure that we're steering this in the right direction? And then three, I think concrete pavements could have a lot of good advantages as we look at how the future of how pavements are going to be designed and built in the future. And so one last summary comment. I think we really need to do our best to work more with these high-tech companies to improve the way highways are built so that we could do that together. And that's a quick summary of what's going on. Thank you very much.
Wow, Dan, you and I talked offline, and I've seen this presentation before, and I wanted to bring it back and show it to our audience here, because a lot of people see these technologies and think that it's many, many years down the road, but as you've shown us, they're in play in multiple locations, some overseas, but they're being tested, and the future is not so far down the road.
Right.
You mentioned some of these technologies are not cost effective right now, but as we know with technology, as it advances, it becomes cheaper. Right. So do you see some of these technologies, or which technology right now do you see that maybe is expensive, that might have the quickest turn on becoming a reality as technology advances and becomes cheaper?
Yeah, that's a great question. So the two that seem to be sort of the lowest hanging fruit are, or maybe three that are kind of the lowest hanging fruit. One is solar panels. So all the people that were very interested in looking at putting solar panels on the roadway, because I think they sort of, at the risk of offending somebody, sort of naively just saw this big open road and thought it's so much square area that we could generate all this free energy. And then they realized it doesn't hold up to 18-wheelers. So, but what they have moved on to is they've come up with really cost-effective ways to put solar panels in the median, or put solar panels on, in the right of way off to the side of the road, in grassy areas, or at like major highway intersections where you have overpasses and a big grassy area. So that is showing a positive return on investment. That's more cost effective. Number two is the V to X stuff, the sensors, the roadside units, and the sensors that you need to get vehicles communicating to each other and communicating to the cloud. That the cost of that is just because all this Internet of Things stuff is, tech is becoming so cheap. They're finding that that's becoming very cost effective, and that is low hanging fruit because you can outfit a major stretch of highway for like less than $100,000 now and really boost your safety capabilities for that highway. So that's a pretty big one. And then the last one that we're discovering is using those same roadside units. We can now get cars talking to each other to increase the throughput on a toll lane. Right? If we have the cars talking to each other a little bit more, we can reduce traffic congestion, get more cars through. And so that becomes a moneymaker for the state. So that's kind of a no-brainer. And so those are kind of the three things that we see that are probably going to be the first things to roll out.
Okay, great, thanks. And we did have a one question come in, and I think it's a good one, and maybe you don't know the answer, or maybe it's something that we could research and get back to the person. But as vehicles become more fuel efficient, and as electric cars become more prevalent, a lot of state DOTs are losing funding due to reduced gas tax collection. And so the question from our audience is there any technology, or is there merit in developing a technology that would report vehicle road use by ton per mile, for example, as a way to maybe replace the gas tax?
That is a very cool idea. And I can tell you that I have not seen that yet. So, there's, the most likely alternative, which, so many people bristled about vehicle miles traveled. But that seems, all the information that we come across kind of points in that direction, that is the most likely place that we're going to go, because it's easy to measure and it's easy to track. But the idea of tons per mile is a pretty smart idea, but I haven't seen anybody develop that yet.
All right. Well, here's a thought. Maybe you and your team could develop that. I would help you market it, and I would be happy to be on the path with you on that one.
I will be emailing you an NDA before the end of this conversation.
Perfect. And then just one last thing. I was really intrigued by the portion of your presentation, actually by all of it, but when you look at how we can improve workplace safety, alerting drivers, and alerting our workforce that's out on the roadways. This is something that's been really important in North Dakota. We've engaged in the Vision Zero program, doing a lot of technology improvements, currently doing some safety corridors in high crash areas. How soon could some of that technology be made available, and how close are we to getting some of that out into the marketplace and making it more common?
Well, within 5 years, because the iCone company is already for sale. Those products. So, I live in Texas, and so I talked to a lot of our friends at Texas DOT, and they were very interested in the iCone products until they found out how expensive they are. But I hope I'm not too offensive to the iCone folks. But what the Texas DOT folks said is they looked at it and they thought, that actually is not that complicated for us to develop internally. And so I think it was more that it gave Texas DOT folks the idea that we could actually start implementing some of these safety measures into our work zones, very soon. Easily within the next 5 years. And then some of these test facilities like the Ray in Georgia, they are working on using roadside units and all this V2X, vehicle to everything communication for work zone safety and to be able to better alert drivers. And so, 5 years is not an unrealistic estimate.
Great. Just have a couple minutes here left. We've gone through the questions in the queue. Is there anything else that Transtec is working on that maybe, keeping in mind our audience is a lot of consulting engineers, some city, county, and state engineers, some concrete contractors? What are some of the cutting edge things that your group is working on right now that maybe we could benefit from or seek out additional information?
Well, Art, if you're asking for a shameless plug, like I'm on a nighttime talk show, the two most interesting things that we've got are, one, lots of state DOTs are curious about all this fancy new technology, but don't have the budget for it, right? And so what we've been doing is helping state DOTs who don't have the budget, kind of quickly assess, for a lot less money, quickly assess what technologies are kind of lowest hanging fruit. What are the things that are most realistic that they should be implementing? So that's one thing that we've been helping folks with. And then the second one, that's probably the most interesting thing, is we are mostly a pavement engineering company. So we're doing pavement design, pavement research. We also do pavement testing, like falling weight deflectometer stuff. But we also sell a concrete temperature and maturity sensor for either pavement repair or also for non-pavement things, vertical concrete construction. And we just introduced a device that's fully autonomous, so that you never have to be on the construction site anymore to collect your concrete temperature or maturity data. It goes straight from the sensor to the cloud to your laptop or iPhone or whatever you have. And so that's available now, which is pretty neat.
Well, that's great, and you know, it wasn't too you know, I gave you the opportunity, and I'm familiar with you and your group, and really think highly of a lot of the work that you've done, and you know, keeping track on some of these technologies. So I want to express my thank you and, you know, our gratitude for you taking an hour to bring us a glimpse at emerging technologies. And certainly I have a feeling that people will be reaching out to you after this event. And with that, we will let you go. But Dan, thank you for a very enlightening past hour. Very, very entertaining, very educational. Thank you very much.
Sure. Thanks for the opportunity, Art. Appreciate it. Thanks, everybody.
Sounds great.